It's about ethical supply. It's about getting the best value out of the supply chain. We can't continue to throw these things away.
Hello, welcome to Assay TV. Today we're talking with Adrian Griffin, who is the Managing Director of Lithium Australia. Lithium Australia aims to supply ethically and sustainably sourced materials to the battery industry. This includes both mining and processing of raw materials, the processing of mine waste, and also the recycling of used lithium-ion batteries. Adrian, great to see you here today. You've got a lot going on in your company at the moment, a lot of exciting news coming out. Tell us about some of the highlights. What's going on?
Well, you're quite right. Things are very, very busy. And in fact, it's pretty interesting. Since COVID kicked in, we've got even busier. But it has affected the business a little bit. And as you mentioned, we cover just about all facets of the battery industry, from production of raw materials right through to battery production in China. We've got a little cathode plant in Brisbane, pilot plant. We make cathode materials there, send them to China. We make commercial format batteries in China. They're for testing purposes only at this stage, and I'm glad to say that the quality of those probably exceeds anything that's available on the Chinese market at the moment. So that's going very, very well indeed. And then we import batteries. We sell energy storage units into the Australian market, both residential and industrial. And at the end of life, we recover those batteries, and we have the technologies available to recover the battery metals and effectively rebirth the batteries. And that's what's creating, I think, a lot of the interest at the moment. Society can't continue to just throw things away. And if you look at the battery industry, it's very, very wasteful. And that waste starts from the mining and production of concentrates, where spodumene producers recover somewhere in the order of 50 to 70% of the lithium units they mine, and the rest go to tailings. Now, the reason they go to tailings is commercial processes that are available today aren't capable of recovering that lithium. And to some extent, it's a matter of physical processing, the way it's done. First step of the process is in rotary kilns. You get solids moving in that direction, gas flow in the opposite direction. If the particles are too fine, they blow out of the rotary kiln. So very sensitive to particle size, also very sensitive to impurities that you have in that material. We've developed a process that will take fine particles with ease and isn't sensitive to the impurities in those materials. So we can produce a very pure lithium phosphate. Now that's interesting. We haven't gone the same route as others that go hydroxide and carbonate. We've gone phosphate because you can control the water balance. You don't have to evaporate water. Lithium phosphate's not very soluble, so it's very easy to drop out, and it's easy to refine. So it's cheaper to manufacture. You get a better product, and that product can go straight into the production of LFP batteries. Now, LFP, lithium ferrophosphate, is the safe lithium-ion battery, and we're seeing governments around the world now starting to legislate that EVs, because of the potential fire hazard that you have with other competing chemistries, NCM and NCA, nickel, cobalt, manganese, and nickel, cobalt, aluminium, they tend to suffer from thermal runaway problems. And we've all seen it on YouTube with Teslas catching on fire and that sort of thing. And as a consequence of the battery chemistry, really, LFP doesn't do that. So we've developed a system that goes straight from waste spodumene into the production of LFP. Not only that, we've done exactly the same thing with respect to spent lithium-ion batteries. We own a company called EnviroStream. It's a 90% subsidiary of Lithium Australia. It is Australia's only mixed battery recycler, the only recycler of lithium-ion batteries in the country. We currently collect those batteries, shred the batteries, separate the components, and then the residual materials, the active materials out of those batteries, we reprocess. At the moment, most of that goes through a partner of ours, Sungil High Tech in South Korea, the largest refiner of those sorts of materials. But as the market grows and we have the justification for putting in the capital, we will refine here in Australia. But we have, on a laboratory scale, taken that material and rebirthed it as batteries through our cathode plant in Brisbane and produced batteries that are, if not as good, perhaps better than the original product. So we have, under those circumstances, gone full cycle. We can take waste material out of the ground, we can produce batteries, we can take those batteries, rebirth them at end of life and start the whole process again. So that's what it's all about. It's about ethical supply. It's about getting the best value out of the supply chain. We can't continue to throw these things away.
You mentioned that the spodumene process is only processed between sort of 50 and 70%, and the rest goes to tailings. That must produce an awful lot of material. What sort of tonnage are we talking about?
Today, if you look at it in terms of lithium carbonate equivalent, which is a rather strange unit to use, but that's what everyone quotes in the industry. Today, the units of lithium carbonate equivalent produced around about 300,000 tonnes, more than half of that going into the battery industry, I might add. So we're throwing away around about the equivalent of that on an annualised basis. Now, that does create a sustainability problem because it doesn't give you maximum utilisation out of your resource base, out of your reserve. So if you can pick that additional material up, and imagine digging a hole, for example, to extract, let's say, 50,000 lithium carbonate units, why not get 100,000 out of the same size hole? So by implementing this sort of technology and having the capability of processing those waste materials, be they spodumene fines, contaminated spodumene, or for that matter, the spent batteries, by doing that, we can get the operating cost right down and improve the value of the product that you give the consumer.
And what sort of relationship do you have with the people who are producing these tailings? Do they just want you to take them off their hands, or are they working with you to process them and feed it back into their supply chain?
Oh, let me say, at the moment we're dealing with a number of the larger concentrate producers and lithium chemical producers to commercialise the process. At the moment, we've done that process, which is called, incidentally, LIENA, L-I-E-N-A. We've done the LIENA process on bench scale. We currently have a government grant to build a pilot plant, and we're approaching those chemical producers and concentrate producers to partner with us to commercialise that process.
And in terms of recycling batteries, again, what sort of volumes are we talking about here?
Well, it's interesting. If you look at it on a global basis, it's estimated that only about 9% of the batteries that are produced get back into the supply chain. The majority of the rest of them go to landfill. In Australia, the figure is significantly less than that. And in Australia, there's about 20,000 tonne available. We're collecting at the moment about 600 tonne annually. There's going to be an interesting change in the Australian landscape with respect to spent batteries in the near future, and that is there will be a stewardship scheme introduced. Now, that stewardship scheme will charge a levy on the battery at the point of purchase. That levy will then go back to cover some of the collection cost and some of the recycling cost. Effectively, that will commoditise that waste material, place a price on it, it'll have a value, and as a consequence, we anticipate that a lot less of that will go to landfill. So we see that system being implemented in the next couple of months in Australia, and within 12 months it'll be running full throttle, and we anticipate that the volume of batteries available to us will increase dramatically. Now, Australia is not the only country doing that. There are many stewardship schemes around the world. The UK we see as an interesting location, and in fact we are looking at various other jurisdictions around the world where we can duplicate what we've got here in Australia and capitalise on the waste batteries that are available to us in those jurisdictions.
And with the uptake of e-vehicles rising rapidly, the amount of materials for you to recycle is going to increase exponentially.
Oh, without a shadow of a doubt. You know, we're talking today about relatively small quantities, and 5 years out, spent batteries in literally the millions of tonnes.
Mm-hmm. You're also involved, obviously, in the mining of raw materials for lithium-ion batteries. Tell us a little bit about what you're doing in that space.
Well, we're not so much in the mining space. We do a fair bit of exploration, and we've got one resource in Germany. Currently, we've got that on care and maintenance due to low lithium price. We'll review that situation in due course. But yeah, on the mining side, most of what we're doing is developing the processing technology to get better utilisation out of the resources. Now, that's not only the process that we've got for processing the off-spec spodumene, but also processing other lithium minerals through a process that we've got called leach, which is a fluorine accelerated leach, ideally suited for the processing of micas. Micas haven't to date been a major source of lithium, but they are developing a fair bit of interest in China, where the lithium micas are produced as a byproduct of mining tantalum.
And what does your process involve?
Takes the lithium mica, you produce a concentrate of lithium mica. You then digest that at elevated temperature, around about 100 degrees C, in sulfuric acid, with the addition of some calcium fluoride, which accelerates the process. And then the types of chemistry that we've been talking about previously, with the lithium phosphate in particular, gets added to the back end of that to precipitate the lithium as a phosphate, and then we can use that as direct feed into the production of LFP batteries.
But at the early stage of that process, it's a lot less energy intensive than the traditional methods.
Well, it is indeed, and if you look at it all under one umbrella, the sulfuric acid, if you produce the sulfuric acid on site, the process is exothermic and probably supplies more energy than you need to run the process. So you can effectively become an energy exporter. The surplus is pretty small, I might add, but yeah, the energy footprint is small indeed.
You also have a subsidiary, a VSPC, looking at sort of some nanotechnology to produce very specific battery chemicals, battery materials. Tell us a little bit about that.
Yeah, well, again, there's the common thread there, of course, Leo, in that we just love LFP, because LFP, lithium ferrophosphate, the safe lithium-ion battery, has a number of attributes that are just incomparable with other batteries. They operate over a much broader temperature, from, say, minus 30 degrees through to plus 50 degrees. They don't suffer from thermal runaway. They have much better longevity. They're cheaper to make. It sounds almost perfect. The one thing that they suffer from a little bit is energy density is about 20% lower than the competing chemistries. I always used to say you're never going to put LFP batteries in your Tesla, but what's Elon Musk done in China? The new model Tesla, it's powered by LFP. Now, why is that? Cost and safety. So what we've done is focused our nanotechnology on producing LFP batteries or LFP cathode powders. The method we use is nanotechnology at its simplest. It's really elegant. We mix up the soup, so to speak, with the right chemistry, with all the elements in the right ratios. We hit that with a surfactant. We then spray dry that, heat treat it, and there's your cathode powder. Very, very simple indeed. And by using that process, you get very exact control over the chemistry. You get exact control over the particle size. And as a consequence, we can produce cathode powders with much better quality control than just about anyone else on the planet. That, as I mentioned earlier, is being exported to China at the moment for the production of commercial cells. We also had that material on test with a number of battery producers in Japan. So very successful indeed. And we have within that company, VSPC, another government grant, which is a very interesting one. the Australian government is pretty keen on electrifying the public transportation system, but that has its own problems, and to some extent it revolves around the rate at which you can charge a battery to make sure that the vehicles that you're transporting people in can keep going throughout the day. So we have a grant to develop a rapid charge battery for use in public transportation, trams in particular. Typical of the politicians, the first place they're going to electrify is Canberra. So they need a tram battery and not a bus battery. So, but we're happy with that, and we've partnered with CSIRO, University of Queensland, and one of our subsidiaries, Lithium Australia, which currently sells energy storage systems. We've partnered with those organisations to produce this battery under the terms of a co-funded government grant. And the target ultimately is to have something that'll charge in minutes rather than hours. So the tram can run down the tracks, pull up while it's offloading people, take a bit of a charge. It might not be a full charge, it might get 20% back into it, but at least it can keep running around all day without having to have a long charge, go back to the depot, top up at night time, start again in the morning. Now, that's going to have very broad application in other transportation sectors, marine applications, military applications, so on and so forth. So we're very excited about that, and we know we can do it. It's a matter of proving we can do it on a commercial scale.
Mm. And what are the plans then for the rest of the year for maybe scaling up some of these businesses that you're working on?
I think the first couple, in fact, you've got to have a look at what we've done with the whole business as a consequence of COVID. We've put it under the microscope. We've cut back on things that aren't going to produce short-term cash flow. So our R&D activities aren't running at the same rate they used to. We haven't stopped them. They continue to move along, but a little bit slower. And we're accelerating the things that will produce near-term cash flow. And those things are the recycling division in Envirostream and Lithium Australia, the energy storage sales division. So you'll see a lot of news flow out of those over the next 12 months or so. And I think with Envirostream, I have mentioned that we're looking at jurisdictions outside Australia. So we want to expand that business, and it's really a matter of cloning the plant that we've got in Melbourne, building new ones in populous centres to save you transporting batteries. One of the problems that you do have with lithium-ion batteries is the transportation of those materials is considered transportation of dangerous goods. So there are permitting issues, special transportation issues. Once you've shredded those batteries and separated the components, you've completely denatured the dangerous materials inside those batteries, and you no longer require permits to move them. So it makes a lot of sense that you do at least the first part of the processing close to the source of the batteries. So in Australia, we'd look at the major population centres. At the moment, we've got Melbourne covered. We'll certainly go to Sydney and Brisbane, and then looking at other locations around the world. I've mentioned that we have an interest in the UK, and certainly our neighbours across the Tasman, who don't seem to have a problem with COVID at the moment. In New Zealand, that's a pretty interesting location to look at too. They, per head of population, have a very large battery consumption, and to a large extent it's a consequence of importing second-hand EVs from Japan. So there are a lot of EVs running around New Zealand, more so than there are in Australia. So there is a very good source of spent batteries in that country.
Fantastic. And obviously the opportunities for expansion of this around the world are endless almost.
Oh yeah, they are. And at the moment the installed capacity is measured in tens of thousands. And I mentioned previously that within a couple of years, we're going to be staring down the barrel of millions of tonnes of batteries per annum to deal with. So it's going to take a hell of a lot to keep up with it.
Well, lots of interesting news flow ahead, I think, for the rest of the year. Lots of exciting projects you're working on there. Best of luck as the year progresses.
Thank you very much, Leo.